Well, whether it is news of the Zika virus hitting the Americas or new superbugs resistant to antibiotics, germs and viruses get our attention, and rightly so. Jason Tetro is here to help us distinguish the science from the scare. He is a microbiology researcher and also the author of the Germ Files. Hello, welcome to the agenda.
Hey, it's a pleasure to be here.
So it seems to me, at any rate, that almost, monthly I watch the news or I read in the paper about some new kind of, germ virus that is on the move.
Yes.
And I don't know if I'm supposed to be scared about it, but you will tell me that. So the latest one we're hearing about is Zika virus.
Zika virus.
What the heck is the Zika virus?
Well, I mean, for 70 years, no one really knew what Zika virus was. It was discovered in the jungles of the Zika forest in Uganda back in 1947. And it's very similar to dengue virus and one you probably know, West Nile virus. Back in 2006, it was doing a whole bunch of things here in Canada. Now, it was essentially spreading in Africa and maybe in the Middle East for, about 60 years. And then in 2007, it ended up going into Micronesia, which meant that it was somehow spreading. And then last year, it ended up in Brazil. Now, this is normal. We expect this to happen with viruses all the time. And because the virus doesn't cause a huge problem most of the time, you get a rash on your trunk and your arms and your legs, you get headaches, you also, might have a little bit of arthritis. We never really thought much about it. Like, you get it for a week and it's gone, right? But now we're seeing that there are these secondary symptoms, what we call sequelae. And one is very important, and that is microcephaly, which is babies are being born with smaller heads than usual, which is suggesting that there's something going on in the neurodevelopment of the brain while the fetus is essentially growing up.
Okay, so it's a mosquito-borne illness.
Yes, it's
so
mosquito-borne.
like West Nile, that's the comparison. So West Nile made it up here.
Yes.
Does that mean that Zika's headed our way?
No, and the reason for that is the mosquito, the Asian tiger mosquito or yellow fever mosquito, doesn't happen or it doesn't live in Canada. And it's because we have the colder winters, and essentially it just can't overwinter itself.
Okay, and then the other thing I want to ask you about is you said this is not really that big a deal for most people. You get a rash, you get a bit of stiffness in the joints. Okay, but then you mentioned these secondary effects that we're seeing. This has to do with pregnant women, and pregnant women are being told, don't travel to places where Zika is showing up.
Exactly. Now, we don't have a definitive link. I actually wrote about this in the academic journals, whereby we have a mechanism that probably could be happening, but we haven't identified it properly. So it's an association as opposed to a causation. That being said, if you're a mother or someone who's pregnant, the last thing you want to have is essentially something happen to you as a result of a lack of knowledge. So it's better to be preventative and to be proactive by essentially saying, if you are in a high-risk position, you are pregnant or you're going to be pregnant, maybe don't go to these regions for a while. El Salvador, that is a little bit of a different thing, where they've told women not to get pregnant till 2018. I think that might be a little bit harsh, because right now we see that if you get Zika virus, you probably won't get it again. You develop immunity to it. So what I'm hoping for is that there's a wave that's going to go throughout the Americas, and then Zika, much like West Nile virus, will disappear.
As a layperson, am I supposed to be alarmed by Zika virus right now?
No, not at all.
Okay.
What you really need to be aware of is that these viruses are going to travel. And if there's any concern for the average person, it's the fact that it might be sexually transmitted. So if you do happen to have that rash on your trunk and your hands and your legs after having been in one of the American countries that has the virus, be a little bit more precautious when it comes to your sexual relations. And if you are, looking at pregnancy, also be a little bit more precautious. That's about it. So don't worry about a number of other issues that people constantly bring up. We don't want Zika to turn into the next Fearbola, put it that way.
Fearbola.
Fearbola.
Okay. I do want to talk about Fearbola. Well, I mean, you're here to distinguish, as I said, the scare from the science. So let's do that. So let's talk about, I think it was a few weeks ago, a few months ago, it was like, we're going to run out of antibiotics. Again, I'm taking this to further lengths than it ever was sort of reported, but like, woe is us, it's all over, we're going to have no more antibiotics. And so I want to talk to you about MCR1. This is an antibiotic-resistant gene.
Yes.
You talked about viruses. I can talk about bacteria. I don't understand how genes can be a threat.
So antibiotics are focused solely on bacteria. And the way it works is an antibiotic targets a bacterial mechanism, stopping it or breaking it down so the bacteria can no longer live.
Okay.
Okay. Now, the way that you and I live is our DNA has genes, and those genes form proteins, and then those proteins form whatever we are, right?
Okay.
Bacteria do the same thing. They can also develop new genes or adapt to use current genes in a different way, evolution, as we call it. And when that happens, what it might also do is change the way that it looks to an antibiotic so that it becomes ineffective. And that's really what's happened in this case. This MCR1, plasmid-mediated colistin resistance 1, if you want, is simply allowing one particular protein, it's called a phosphoethanolamine transferase for those of you who are interested, to change the way that a bacterium looks to a particular antibiotic known as colistin. And as a result of that, it no longer works. That's antibiotic resistance.
Do I have this thing in my body?
You probably don't have MCR1 in your body, but you do have antibiotic resistance genes in your bodies. And so we are all carrying trillions and trillions of microbes, and many of them are going to have these antibiotic resistance genes. Now, it means absolutely nothing because you're not taking an antibiotic. And
all right, but I might.
But you might. And so when you take an antibiotic, then there's a chance that those bacteria are going to resist. The goal is to make sure that the bacterium that you're targeting doesn't have that resistance. And that's where we're failing at the moment.
All right, so let's go back to my role, our audience's role as lay people. What is are you saying to me, don't go to your doctor and get a prescription for antibiotics to treat your common cold? Like what can I do?
Oh, absolutely. We have to reduce the use of antibiotics. I mean, that's really what we need to focus on, because the less antibiotics out there, the less likely we have to worry about antibiotic resistance. Makes sense. If you have a cold or the flu, that's a virus. So an antibiotic, not going to work. If you have a mild urinary tract infection or earache, there's a very good likelihood you can probably get rid of that on your own. It might take 7 days, right? Whereas an antibiotic might take 2. But if you're willing to put in the effort and suffer a little bit of the pain, then there's a good likelihood that you won't be contributing to antibiotic resistance. And now we have a program where we actually can delay prescriptions. So we tell somebody, you have a bacterial infection, but we think your body's going to be able to take care of it. So we're going to delay for maybe 3 days, 5 days. Let's see how it goes. And usually you clear it. So that's how, it's called antibiotic stewardship, but that's really what it comes down to. That's the medicine side.
That's the doctor's responsibility.
That's the doctor's responsibility.
All right, we got a couple of minutes left. I want to touch on something else, something that whether you pick up a tabloid, a broadsheet, turn on the TV, turn on the radio, there is most often a story about a food-borne illnesses. It doesn't seem to go away. And I mean, really, there's a story of it. It's your lettuce, it's your kale, it's your alfalfa sprout. I mean, it's your meat, it's whatever. Is the media just reporting this more, or are we seeing more of these kinds of outbreaks?
Oh, no, we are seeing more.
Okay, and why is that?
Well, it basically has to do with the fact that foodborne contamination happens in one of 3 areas. The first is during culture. So it's either unsafe water for irrigation, or there's bacteria and other pathogens in the seawater for seafood, right? The second is during processing. And what this means is that when the food is going from slaughter to the package, somewhere in there's contamination. We've seen this with Listeria, with Maple Leaf Foods, with XL Foods, with E. coli. And then the third one is preparation. And that's just simply a lack of hygiene. And you have the cross-contamination.
This is the human component.
Well, the last 2 are really the human component. The first one is kind of a human component because we still need to have agricultural food, but what happens when we don't have enough water? We have to start either reserving or reusing. And as a result of that, you get manure contaminating water, which then contaminates your lettuce. And then the lettuce is just simply processed and it's not really handled any differently, but it still has the Listeria or the Salmonella, that type of thing.
I'm going to be honest with you. I sometimes, not all the time, eat like bagged lettuce, right? I'm in a rush.
Yeah, of course.
Whatever. Buy my bagged greenery. And every time I open that bag and it says on it, wash before use, I think, why am I doing this? I'm quite possibly going to get sick from this because it often seems to be these bagged vegetable stuff. So is that because, like, versus a head of lettuce that I buy, is that because humans have handled this thing and somehow it's been contaminated?
Well, actually, you should be washing the head of lettuce anyway.
For the record.
So here's what's happening. When you take a bag lettuce, it's incorporating a processing step, which means that you've added one more potential risk factor into the equation. The reason you want to wash it is because the bacteria that cause infection usually have to you have to ingest a certain amount. Sometimes it's hundreds of thousands of them, right? So you give it a wash, and you're going to flake off a whole bunch of those so that the levels are low enough so it's not going to cause you a problem. And that's really why you're doing the washing. I don't think many people understand that. But when it comes to something like what we're seeing with the most recent foodborne outbreak that made the news with the packaged lettuce.
Yeah, listeria.
Listeria. It's really due to the fact that the listeria is native to the environment, it's in the soil, and if you have a wet soil or a wet season, there's a very good likelihood that listeria is going to grow to huge amounts. We've known this since the 1950s. And then that gets into your lettuce. And then during the processing, if they're not using chlorinated or hot water, then the listeria is going to survive. And then it's eventually going to get into the packaging where it could actually grow to those numbers that are going to cause infection.
Okay, but washing it under my sink, whether it's the head of lettuce with listeria or the bagged one, washing it as you do with lettuce, that's going to help me. That's going to save me from getting this thing, or no?
Well, it'll definitely help to reduce the risk of getting it, and most likely you won't get it because you're very healthy. But about 30% of our population has some kind of compromised immune system. So when you compromise the immune system, that number goes from, say, hundreds of thousands to maybe 1,000. And this is what we're seeing, and this is another reason why we're seeing such a huge number of these cases, is that in part it's the human immune system that just simply can't keep up with the bug.
Here's the thing, the advice has never changed. Hygiene, hygiene, hygiene. Wash.
That
okay.
pretty much is the way to make sure you don't get infected.
Thank you, sir.
It was a
nice
pleasure.
Nice to have you here.
Help TVO create a better world through the power of learning. Visit supporttvo.org and make a tax-deductible donation today.